Good evening from Space Launch Complex 41, where ULA's Atlas V rocket is fueled and ready to launch 29 Amazon LEO satellites to low Earth orbit. I'm Pam Ziert, a mechanical engineer at United Launch Alliance.
And I'm Austin Hill, a weld engineer. Welcome to live coverage of the Atlas V LEO 7 mission. We're joining you from ULA's Advanced Space Flight Operations Center at Cape Canaveral Space Force Station in Florida. In addition to our teams here at the Cape, we have a team of engineers on console at ULA headquarters in Denver, Colorado. Liftoff is scheduled for 7:35 p.m. Eastern Time with a 29-minute launch window. Launch windows for Amazon LEO missions vary by day and are determined by the position of the Amazon LEO satellites currently in orbit. Tonight's coverage will continue through deployment of all 29 spacecraft.
For additional real-time updates, you can follow along with our live blog at ulalaunch.com. And if you enjoy watching our live coverage, be sure to subscribe to our YouTube channel for future missions.
This Atlas V is in a 551 configuration with a 5-meter payload fairing, 5 solid rocket boosters, and 1 main engine on the Centaur 3 upper stage.
We're taking a live look at the Atlas V rocket on the launch pad at Space Launch Complex 41.
The largest portion of the vehicle that you see is the first stage, also known as the booster, which provides the initial thrust at liftoff.
The Atlas booster is typically a copper color, but now filled with super cold cryogenic liquid oxygen, it has turned white with frost. The booster stage is also filled with RP1, or rocket propellant, which is a highly purified kerosene. Together, these propellants fuel the booster stage from liftoff through second stage separation. The second stage is the section above the booster, also known as Centaur. It takes over after first stage or boost flight, guiding the payload to its final destination in space. You can't actually see the Centaur right now as it is covered by the payload fairing. The very top of the rocket is the payload fairing. This protective shell gives the rocket an aerodynamic shape necessary for the climb to space, while keeping the 29 spacecraft safe from the harsh atmospheric conditions.
On the fairing, we're proud to display artwork representing Amazon's LEO program in its signature Krypton color, along with the American flag and the Atlas and ULA logos. The Amazon LEO name is a nod to the low Earth orbit constellation that powers this network. And if you look closely, you'll notice the logo includes an aurora shaped by the letters LEO. As we continue the countdown, let's take a closer look at how ULA builds the Atlas V rocket.
Engineered in Centennial, Colorado, ULA's Atlas V rocket is built in Decatur, Alabama, and launched from Cape Canaveral, Florida. Once the rocket is manufactured, it travels to Cape Canaveral on ULA's cargo ship, known as Rocket Ship. After arriving in Florida, ULA's launch operations team begins assembling the rocket. Stacking begins with lifting the 107-foot Atlas booster, powered by an RD-180 engine, onto the mobile launch platform. 5 solid rocket boosters are attached to the sides of the first stage for additional thrust at liftoff. ULA's ultra-thin stainless steel Centaur upper stage, powered by an RL-10 engine, is then lifted into position. Lastly, the payload fairing, containing the spacecraft, is lifted and mated to the Atlas V rocket. Once assembled, the countdown begins with moving the rocket from the vertical integration facility to the launch pad. The trip to the pad is about 1/3 of a mile. Throughout the 20-minute trip, a payload van leads the move, providing communication with the spacecraft, followed by the ground van providing support to the rocket. The mobile launch platform supplies air conditioning, electrical, and propellant lines to the rocket. Track mobiles at the rear power the convoy, which includes an environmental control system, providing air conditioning to the payload and rocket, as well as a backup generator. Atlas arrives at the pad for fueling and other final preparations, and once fueled, weighs nearly 1.3 million pounds.
So we just learned how ULA processes the Atlas V rocket at the launch pad, but let's take it back a step to when we actually build it in the factory. So Austin, as a weld engineer, can you tell us a little bit more about how we manufacture the Atlas V?
Yeah, absolutely. So the booster has a liquid oxygen tank and an RP1 tank. The liquid oxygen tank has 2 barrels, and those are friction stir welded together. RP1 has 1, and it's also friction stir welded. And then our pressure welds done horizontally are the arc welding processes, which I was ahead of welding engineering-wise. Those are done with variable polarity plasma arc welding, and then we had some structural welds done with variable polarity glass tungsten arc welding.
That's really interesting that Atlas also has friction stir welds because the Vulcan vehicle has taken the flight success of those welds and implemented that on our Vulcan booster as well.
Tonight's mission will deliver 29 Amazon LEO satellites to low Earth orbit. Identical to the payload integration of the Atlas V LEO 5 and 6 missions, the team added a 4th level to the satellite dispenser system, allowing more satellites to fly in a single launch and further accelerate deployment of the constellation. This was all made possible by engineering work between Amazon LEO and ULA to use additional performance from the RL-10C upper stage engine.
Around the world, billions of people still lack access to high-speed internet. Amazon LEO is working to deliver fast, reliable internet to customers and communities beyond the reach of existing networks. Let's take a closer look.
And the next equation is 18 minus 8 equals 10.
Liftoff. Stage 1 at
So Pam, summertime is pretty exciting here at ULA. We welcomed a lot of our interns back on May 18th, and special shout out to the Decatur ones. But yeah, it's a really fun time around here.
Yeah, so we welcomed over 80 interns across all of our sites. So that includes both launch sites at both coasts, as well as headquarters in Denver, our test facility in Pueblo, Colorado, our factory in Decatur, Alabama, and even our wash ops in Washington, D.C. And for those of you who don't know, we have internships across many different disciplines, engineering, sciences, and especially even our business teams. And you can see some pictures of them going across the screen right now.
Yep, and I know I was an intern a little while ago, and you were as well, correct, Pam?
Yes. Yeah, one of the things that I think I enjoyed most about the internship was actually not during the day. After work, we had the opportunity to work on some sport rockets with some mentors for the interns. And that was a really good opportunity. You see the picture there where luckily I was not a permanent payload in that. That was an opportunity for us to get some hands-on experience in addition to our day jobs.
Yeah, I know Decatur and I think another site, Florida, of course. We're doing L1 and L2 sport rockets as well over the summer, so we'll get a little taste of our own launch days in our own areas, so it'll be very fun.
Very cool. So I enjoyed the internship mostly because I actually felt like I was doing meaningful work. I wasn't working on boring spreadsheets. I was designing flight hardware and learning how to be an engineer before I graduated. Did you have a similar experience?
Oh, yeah, absolutely. I got all my initial experience doing Atlas V welding engineering at my internship, and that directly translated into my full-time job, so I was very grateful.
Yeah, it's a great experience, and if anyone, any students are interested, our applications open the end of the summer, the Tuesday after Labor Day, and those will be for the 2027 summer, so we hope that you can join us. As we get closer to the opening of our launch window, let's take a look at the weather forecast from the Space Launch Delta 45 weather officer. Today's forecast for launch is looking better than it has. The probability of violating launch constraints is 55%. Ground winds are 2 to 5 knots out of the east, and the temperature is 77 degrees Fahrenheit. The primary concerns for launch are the anvil cloud rule and the surface electric fields rule.
Once Atlas lifts off, viewers watching this launch from Florida and up the East Coast into New England may be able to see the rocket in flight. To get a closer look at this visibility map, check out @ULA Launch on social media.
L minus 10 minutes. All communications switch to channel 1. All personnel and visitors remain in present position until launch. Maintain operational silence in the LCC.
Terminal count briefing. If a condition exceeds a launch constraint any time after the terminal count status check, the observer shall announce hold, hold, hold on channel 1. Identify their station to briefly state the reason for the hold. Flight control. Perform launch on time verification.
Roger.
OSM, place SRB ignition SNA switch in the enable position.
Enabled.
LOX 2, verify CSA purge flowing GN2 to the CISA.
Verified.
OSM, verify the FCO, ROC, and OSM hold fire switches are in the proceed position.
Confirmed.
RLM, verify red line monitor and vent table are in the correct configuration for terminal count.
Verified.
RC, verify solar radiation acceptable for launch.
Verified.
Launch on time verified.
Roger. All steps are complete prior to the status check. LC switch to the ready position.
L minus 8 minutes.
We remain in the planned 30-minute hold as we continue toward liftoff.
In just a few moments, ULA's launch conductor Scott Barney will poll the team for the final go to resume the countdown.
The launch conductor oversees the team during this process, confirming that all systems are operating normally and that the countdown is proceeding as planned. A total of 28 engineers will be polled to confirm the rocket is ready to move forward.
This is the final status check of the Atlas V vehicle, ground systems, the payload, and the U.S. Space Force Eastern Range. Let's listen in as the team conducts the poll.
L minus 7 minutes.
Status check to proceed with terminal count. Atlas systems propulsion.
Go.
Hydraulics.
Go.
Pneumatics.
Go.
LO2.
Go.
Water.
Go.
Centaur systems propulsion.
Go.
Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
HASGAS.
Go.
Electrical systems airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
GCQ.
Go.
Op support.
Go.
COM.
Go.
Umbilicals.
Go.
Environmental control systems.
Go.
Red eye monitor. Go. Quality.
Go.
Ops safety officer.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
Go.
Range and weather.
No go due to weather.
And do you have estimated clear?
Estimated clear time is 23:45 Zulu.
Roger. Launch director, we have a no-go for weather. Expect to clear 23:45.
Copy. I'll be coming back to you with a new T0 momentarily.
LC, not ready. Team will stand by here awaiting a new T0.
Polling is complete and the team is no-go for launch due to weather constraints. We're awaiting a new T0 from the team, so please stand by for more information. This is Atlas Mission Control at L-4 minutes and holding. We are currently in our planned hold while we wait for a new T0 because of weather. As you just heard in the poll, the range reported being red. However, for launch to continue, they would be referred to as green. For context, the range, or the Eastern Range, refers to a designated area extending from Florida through the southern Atlantic Ocean. The range, operated by the U.S. Space Force, supports rocket launches from the east coast of the United States. This area is considered and reported to the launch team as green when the flight path is clear of boats or aircraft. In addition to keeping the public safe, the range also supports launch providers with communications and telemetry, as well as rocket tracking when in flight and weather forecasting.
LCLD.
Go LD.
Please coordinate a new T0 of 235300. That's 2353 Zulu.
Roger, 2353-000. ALC, please set the clock, 2353-000.
Roger.
RCLC,
Go for RC.
please coordinate with the range, new T0, 2353-000.
Roger.
LC, ALC.
Go.
Countdown clock has been set with new T0 of 23:53 Zulu.
Roger.
We are still in a hold for weather, but we are looking at a new T0 at 7:53 p.m. Eastern Time. The range is still no-go, but we will be waiting to see if that clears again.
LC, RC, channel 1.
Go RC.
The new T0 of 23:53:00 Zulu has been coordinated and approved on the range.
Roger. All right, team, we have an approved T0. Yep. L count is about to hit L minus 13 minutes. We'll re-perform the status check at L minus 7 minutes.
This is Atlas Mission Control at L minus 11 minutes and counting. We've coordinated a new T0 with the range of 7:53 p.m. Eastern. Rocket ship and spaceship, which will soon join ULA's fleet, are ULA's specially designed cargo ships, delivering our rockets to launch sites in California and Florida. Let's take a look at this unique capability.
Following production in Decatur, Alabama, ULA's Vulcan rockets are shipped to launch sites in Florida and California using ULA's specially designed cargo ships. Rocket ship, currently in use, and spaceship, which will soon join ULA's fleet, each span more than 300 feet and carry more than 500,000 pounds. Designed to navigate the open sea or narrow rivers and maneuver in depths as little as 8 feet, these are no ordinary cargo ships. Traveling with several professional mariners, this certified crew includes the captain, navigational officers or captain's mates, engineers, an oiler, a bosun, seamen, and stewards, as well as river advisors when traveling through Baton Rouge. Delivering Vulcan to the launch site begins with designing the load plan, which is a blueprint showing how and where rocket components will safely fit in the ship's cargo bay. The load plan includes the lashing plan, detailing how rocket components will be secured during transportation to prevent shifting or tipping in rough waters. With the load plan approved, ULA's Decatur technicians transport hardware to the dock, then load and secure each rocket component in the ship's cargo bay. Once fully loaded, the crew prepares for their departure. Casting off from Alabama on the Tennessee River, about 556 feet above sea level, the crew navigates through numerous locks and dams as they pass through Tennessee and the Tennessee Wiggles. To accommodate for weight imbalances in the cargo bay, the chief mate is responsible for ballasting the vessel, which requires pumping water in and out of the ship's ballast tanks to maintain the stability of the ship. Entering into Kentucky, the ship merges onto the Ohio River, followed by a turn south, all the way down the Mississippi River. Passing through Baton Rouge, then New Orleans, the ship nearly reaches sea level. At the Gulf, the route varies depending on the destination. For shipments to Cape Canaveral Space Force Station in Florida, which takes approximately 8 to 10 days, the route continues southeast across the Gulf around Dry Tortugas, the most southern point in the U.S. After following the Florida Keys into the Atlantic, the ship arrives in Port Canaveral. For shipments to Vandenberg Space Force Base, the route continues southeast, crossing through the Gulf and into the Caribbean Sea. After passing through the Panama Canal, the crew enters the Pacific Ocean for around 12 days and arrives to the dock at Vandenberg after approximately 21 days of travel. At either destination, the flight hardware is then unloaded and transported for stacking and launch.
Following the range being no-go due to weather, the team will now repeat the poll.
As a reminder, this is the final status check of the Atlas V vehicle, ground systems, the payload, and the U.S. Space Force Eastern Range. Let's listen in again as the team conducts the poll.
L minus 7 minutes.
Status check to proceed with terminal count. Atlas systems, propulsion.
Go.
Hydraulics.
Go.
Pneumatics.
Go.
LO2.
Go.
Water.
Go.
Centaur systems, propulsion.
Go.
Pneumatic.
Go.
LO2.
Go.
LO2. LH.
Go.
ASCAP.
Go.
Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
GCQ.
Go.
Op support.
Go.
Com.
Go.
Umbilicals. Umbilicals.
Go.
Environmental control system.
Go.
Red line monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
Go.
Range and weather.
Go.
Launch director.
You have permission to launch.
Proceeding with the count. ALC verified T0 is set for 23:53.
Polling is complete and the team is go for launch. From now until liftoff, ULA's launch conductor will lead the team through the final steps in today's countdown. This includes verifying propellant levels and pressures in both the booster and Centaur tanks, as well as arming the ordnance for ignition, stage separation, and flight termination.
At T-minus 1 minute, the range will confirm it is in a green condition for launch, meaning there are no constraints such as boats, aircraft, or weather, and that all tracking systems are ready. At T-minus 25 seconds, you'll hear Go Atlas, Go Centaur, Go Amazon Leo, the final status check for the rocket and payload. In the final seconds, the launch pad's water deluge system will activate, followed moments later by booster engine ignition.
Then, after liftoff, you'll hear ULA's flight commentator Sarah Kelly providing live updates as the rocket ascends into space.
This is Atlas Mission Control at T-minus 4 minutes and counting. We anticipate releasing the hold in a few minutes. These planned holds allow for the team to work through any issues that may occur during the launch count.
You may have noticed the countdown clock in the top left corner of your screen. This clock represents the amount of time remaining until launch, including the time during the planned holds. The engineers follow the T-minus count, which represents the time remaining until launch without the planned holds.
Three, 2, 1, mark. 4 minutes and counting. 3:55. Ground pyros enabled.
The countdown clock has resumed, and we are go for launch at 7:53 p.m. Eastern. After liftoff, ULA's Atlas V rocket will fly northeast from Space Launch Complex 41. Here's a look at today's flight.
Following final confirmation of rocket readiness, the RD-180 engine and 5 solid rocket boosters ignite to produce more than 2 million pounds of thrust lifting ULA's Atlas V rocket away from the pad. Shortly after liftoff, the rocket begins a pitchover to attain the proper flight path while minimizing the dynamic pressure it experiences during flight. Atlas then reaches Mach 1, the speed of sound. The addition of 5 solid rocket boosters, or SRBs, precisely augment the liftoff thrust of the Atlas V, giving it the power to deliver the payload to orbit. With their propellant expired approximately 96 seconds into ascent, the SRBs burn out, followed by jettison. Atlas's guidance system then begins steering towards the precise target in space. Amazon's LEO satellites are encapsulated inside a 5-meter diameter payload fairing, which provides protection to the spacecraft during ascent. After crossing the Kármán line, entering space, the payload fairing is jettisoned. With the majority of propellant expended fighting against the force of gravity, the RD-180 engine shuts down and the booster stage separates. The rocket then begins second stage flight, weighing less than 7% of what it did at liftoff. ULA's high-performance Centaur, with its RL-10 engine, ignites, powering the upper stage and spacecraft into a circular low Earth orbit. The first burn comes to an end with engine shutdown. Centaur then rotates into the precise position to release Amazon's LEO satellites, spacecraft that will deliver fast, reliable internet to customers around the world.
Securing Centaur LO2. $140. Launch enabled. 137. FTS armed.
T-minus 90 seconds. The launch vehicle, ground systems, payload, and Eastern Range are go for launch. For those of you just tuning in, I'm Pam Ziert, joined by Austin Hill for tonight's live coverage of ULA's Atlas V launch of Amazon Leo 7.
At this time, the team is not working any issues, and we're proceeding towards liftoff at 7:53 p.m. Eastern. T-minus 1 minute.
Stable at step 3.
Verify ECS roost for launch.
Verified.
25.
Status check.
Go Atlas.
Go Centaur.
Go Leo.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2. We have ignition. 1, and liftoff of the United Launch Alliance Atlas V rocket, carrying another 29 satellites for Amazon Leo. These spacecraft will deliver fast, reliable internet to customers around the world.
60 miles per hour. Booster to closed loop control. RD-180 throttling down per flight program. Vehicle parameters look nominal. Pitch over maneuver complete. Roll program complete. Mach 1, Atlas V is now supersonic. Vehicle is traveling down the center of the range track and is 2 miles downrange.
You are hearing the voice of
throttling
ULA's
back.
Sarah Kelly providing launch vehicle ascent data.
Max Q, the vehicle just experienced the maximum dynamic pressure predicted for today's flight.
In about 15 seconds, the first stage engine will throttle down to prepare for separation of the solid rocket boosters.
2,000 miles per hour and is 11 miles from Earth. Main engine is throttling down in preparation for SRB burnout. Vehicle now weighs half of its original liftoff weight.
This is Atlas Mission Control at L plus 1 minute 35 seconds. We're coming up on burnout and jettison of the solid rocket boosters. These additional motors increase the thrust at liftoff, giving Atlas an extra boost off the pad.
And we have positive indication of separation for all 5 SRBs. Guidance initiated. Vehicle has entered a closed-loop steering program.
We are
Vehicle
just
continues
over
down-
2 minutes into flight. Coming up next, the Atlas V rocket will transition to closed-loop steering, meaning it will use real-time flight data to adjust its path.
One thing many people don't realize about launch day is that these key milestones are pre-programmed into the rocket's onboard computer, known as its avionics system.
While it may seem like engineers are commanding each step in real time, that work is done in advance and tested in ULA's System Integrations Lab in Denver. On launch day, the team is focused on monitoring the data coming back from the rocket to make sure everything is performing as expected.
The vehicle is holding acceleration steady in preparation for PLF jettison. RCS bottle pyro.
This is Atlas Mission Control at L plus 2 minutes 50 seconds. In just a few moments, we'll have jettison of the payload fairings.
Confirmation of payload fairing separation and jettison, as well as CFLR deck jettison. RD-180 throttling up as expected.
We've now heard confirmation of payload fairing jettison. This composite fairing protected the spacecraft as it pushed through the harshest parts of Earth's atmosphere.
Coming up is cutoff of the Atlas first stage engine and separation of the booster stage, followed by ignition of ULA's Centaur second stage engine.
These events occur when the first stage has escaped Earth's atmosphere, getting above the Kármán line and entering into space.
ULA's Centaur upper stage, with the Amazon LEO satellites attached, then takes over on a trajectory to a precise location in low Earth orbit. Let's listen in as we approach these milestones.
30 seconds remaining until BECO. We've begun the boost phase chill down to prepare the second stage. PU to open loop control. Boost phase chill down complete. BECO. RD-180 burn has concluded. Booster separation confirmed. Centaur fuel and liquid oxygen pre-start. RL-10 ignition and ramp to full thrust. Performance is nominal.
This is Atlas Mission Control at L plus 4 minutes 50 seconds. We just heard ULA's flight commentator confirm the successful completion of the early milestones in today's flight, and all systems continue to operate nominally. We have about 13 minutes until we reach our next mission event, shutdown of Centaur's main engine. During our break in commentary, we'll continue to stream live animation from flight.
Format switch to TDRS compatible data rates. Signal strength remains nominal. Centaur PU has transitioned to closed loop control. RCS thermal conditioning firings continue as expected. Vehicle continues down the center of the range track and is 680 miles downrange. Preliminary assessment of booster performance has us at +1 sigma to our pre-flight predictions. Expected attitude adjustment to align with TDRS East satellite. PU system operating as expected, working to optimize propellant usage for today's flight. RCS duty cycling as expected. Vehicle is 1,050 miles downrange, traveling at 12,440 miles per hour. Data quality continues to be nominal. RCS line temperatures have converged to bottle temperatures as expected. Vehicle continues down the center of the range track and is 1,430 miles downrange. PU system continues to drive toward an optimal mixture ratio. Vehicle is now traveling over 13,500 miles per hour and is 370 miles from Earth. After MECO 1, there will be a 3-minute coast period before starting today's spacecraft separation sequence. We are carrying 29 satellites that will join Amazon's LEO constellation. There will be 10 deploy events, 3 events per tier, 3 satellites each, and a final 2 satellite separation from the cake topper. Each deployment event is spaced 1 to 3 minutes apart. Each separation will be initiated with an arm command, followed by a deploy command from the ULA flight computer. After the deployments occur, there will be a roll maneuver if required to the next SV separation attitude, and a settling event to maximize the relative distance between spacecraft. After which, Amazon will maneuver their assets to their operational orbits. All vehicle parameters continue to be nominal. Five minutes to MECO. Engine operating parameters continue to look good. Vehicle is 2,600 miles downrange, traveling over 14,900 miles per hour. We are now 15 minutes into today's flight. All vehicle parameters continue to be stable. The U system continues to operate as expected. Vehicle is 3,100 miles downrange, traveling over 15,800 miles per hour. Two minutes to MECO. CS duty cycling as expected. 1 minute to MECO. Vehicle is 3,600 miles downrange, traveling over 16,600 miles per hour. All vehicle operating parameters continue to be nominal. 30 seconds to MECO.
This is Atlas Mission Control at L plus 17 minutes. We're coming up on the end of the first of 2 Centaur upper stage burns.
PU to open loop control. MECO, this concludes the first burn of the Centaur upper stage. RCS on for settling.
We've just heard confirmation of the successful first burn. In about 2.5 minutes, we'll begin the deployment sequence for 29 LEO satellites into low Earth orbit. This will take about 16.5 minutes to complete.
Vehicle parameters remain nominal. Vehicle is now coasting just over 17,000 miles per hour. First separation event coming up in about 30 seconds.
This is Atlas Mission Control at L plus 20 minutes and 30 seconds. We're coming up on the start of the LEO satellite deployment sequence.
Arm command sent. Deploy command sent. Confirmation of 3 LEO satellites successfully separated. Next event in just over 2 minutes. Vehicle has begun performing a roll maneuver for the next SV SEP event.
This is Atlas Mission Control at L plus 21 minutes and 20 seconds. We just heard confirmation of the first of 10 events to deploy all 29 satellites for Amazon's Atlas V LEO 7 mission.
As we've mentioned, LEO is Amazon's low Earth orbit satellite constellation, designed to deliver fast, reliable internet to customers beyond the reach of existing networks. The initial constellation will include more than 3,000 satellites, and their altitude allows for lower latency than traditional satellite systems.
Each satellite uses electric propulsion for orbit raising, maneuvering, avoiding collisions, and safety orbiting at the end of its mission. They also use optical intersatellite links, infrared lasers that transfer data between spacecraft, forming a secure network in space.
To deploy the satellites, all 29 are mounted to a dispenser system attached to ULA's Centaur upper stage. Today's dispenser consists of 3 tiers of 9 satellites each, with an additional 2 satellites on the final tier, referred to by engineers as the cake topper.
Once Centaur reaches the target deployment altitude, the satellites are released 3 at a time, with short pauses in between, starting with the bottom tier. During this process, ULA engineers are closely monitoring data to confirm each deployment is successful and that all systems remain healthy. We have 9 more deployments ahead, so we'll step away from commentary for now and return as we approach the final deployment. In the meantime, we'll continue to show live animation of the mission.
Next SEP event in 30 seconds. Arm command sent. Deploy command sent. Confirmation of 3 more LEO satellites successfully separated. Next event is in just over 2 minutes. RCS on for settling. Begin roll maneuver in preparation of next separation event. Vehicle battery voltages remain stable. Vehicle is 6,300 miles downrange, still coasting just over 17,000 miles per hour. Next SEP event in 30 seconds. Arm command sent. Deploy command sent. Confirmation of 3 more LEO satellites successfully separated. Next event is in 2 minutes. RCS on for settling. Antenna switching TDRS satellites as expected. Thirty seconds to the next SEP event. Arm command sent. Deploy command sent. Confirmation of 3 more LEO satellites successfully separated. Next event is in just under 2 minutes. RCS on for settling. Begin roll maneuver in preparation of next separation event. Vehicle parameters remain nominal. Vehicle is 7,400 miles downrange. "30 seconds to the next SEP event. Arm command sent. Deploy command sent. Confirmation of 3 more LEO satellites successfully separated. Next event is in just under 2 minutes. RCS on for settling. Begin roll maneuver in preparation of next separation event. Fuel tank pressures remain stable. "30 seconds to the next SEP event. Arm command sent. Deploy command sent. Confirmation of 3 more LEO satellites successfully separated. Next event is in just over 1.5 minutes. RCS on for settling. Vehicle is 8,200 miles downrange, still coasting just over 17,000 miles per hour. 30 seconds to the next SEP event. Arm command sent. Deploy command sent. Confirmation of 3 more LEO satellites successfully separated. Next event is in 90 seconds. RCS on for settling. Begin roll maneuver in preparation of next separation event. Thirty seconds to the next event. Arm command sent. Deploy command sent. Confirmation of 3 more LEO satellites successfully separated. Next event is in just under 90 seconds. RCS on for settling. Begin roll maneuver in preparation of next separation event. Thirty seconds to the next event. Arm command sent. Deploy command sent. Confirmation of 3 more LEO satellites successfully separated. Next event is in just over 90 seconds. RCS on for settling.
This is Atlas Mission Control at L plus 36 minutes and 30 seconds. We're coming up on the final LEO deployment in today's mission.
"30 seconds till our 10th and final separation event. Arm command sent. Deploy command sent. Confirmation of the final 2 LEO satellites successfully separated. All 29 LEO satellites have now been successfully separated for our Amazon customer.
This is Atlas Mission Control at L plus 37 minutes, 55 seconds.
We just heard confirmation of successful deployment of Amazon's 29 LEO satellites. As we wrap up our live coverage, I want to say thank you for tuning in to tonight's flight and remind you to visit ulalaunch.com, follow us at ULA Launch, and subscribe to our YouTube channel.
And join us in July for another Atlas V launch for Amazon LEO. Before we sign off, let's take another look at liftoff.
5, 4, 3, 2. We have ignition. 1. And liftoff of the United Launch Alliance Atlas V rocket, carrying another 29 satellites for Amazon LEO. These spacecraft will deliver fast, reliable internet to customers around the world.